difficult session because what I want to do for today, right, actually is I want to go through all of the questions, okay, everything that we have left, but we are going to skip about 2 to 3 of the less important or the easier ones. Then I'm going to give out the guest state notes and then we're going to go through those. Okay? Okay? Start guest state already? Haven't. No? Still can morning. So everybody has still can morning. Oh, the class is so fucking small. What's that? Oh, okay, wait, never mind. No, no. Okay. So you also still can morning. Is it okay? It's become quite manageable after a couple of weeks, right? With the exception of hybridization. Energy. So intense, man. Wait, you all everyday got session.
And last week I was in for like half a week.
Holy shit. Okay, this is like the worst possible time. What the fuck? Excellent, you also. And also haven't been in class. You got no energy, man. What's your CCA?
I don't have energy.
What's your CCA?
Okay.
Oh yeah. Wow. You have energy? Really? Wow. You all decide who can play louder, is it? Oh, what's the plan? Okay, so let me go through first. Alright. So basically, right, for today, okay, we have 3 mini games. Okay, we are gonna finish. Okay, worksheet. Then we're gonna do a chem bonding consolidation. Okay. Your consolidation is going to be your essential roadmap. Okay, so we are going to use that. Okay, what I normally tell students is they can just staple it to the back of their worksheet. Okay, and when you staple it, then that will become your roadmap to finding all the different shit that you need to know. Then after your Chem 1 consolidation, we're going to do gas state notes. Okay, later when I pass out the gas state notes, right, it's actually going to be very, very short. Okay, 1 hour or maybe like 45 minutes like that is more than enough to go through everything. Okay, you have the hardest topic followed by the easiest topic. Okay, so gas state is really, really very simple. Okay, I won't spend too much time on it. Okay? Okay, then next week we'll do a bit of gas state, okay, and then afterwards we are going to start on your chemical energetics training. Cool? Okay, if I'm in front of your school, okay, that's kind of where I enjoy being. But if not, then I apologize for being slow. Okay, come, let's start first. Okay, we are going to do question 5 together, just as a bit of a warm-up. Alright, we have dot and cross diagrams. Draw dot and cross diagrams for the following compounds, hence determine their shapes as well as the angles around the central atom. Okay, just taking a look at this fella, for example. Giselle, now that you have arrived, can you tell me, this fella got any central atom or not? Got. Who? Really? Sodium carbonate got a central atom. Got. Ionic compound we got central atom one. Okay? This ionic compound as a whole doesn't have a central atom. However, in your carbonic ion, yes, okay, he is by himself. He's in the center, okay, of your CO3 2 minus ion. Did you watch the video? Don't like, really? Okay, good. You want to continue? Okay, I'm going to give you guys some time now. All right, work on the 4 examples. Shouldn't be too difficult. Okay. You don't need to draw the resonance structure here. Although, if you want to, you may, for you. I'm just looking for dot and cross. You didn't realize your resonance structure is not dot and cross diagram, right? It's Lewis structure. Huh? Yeah. The lines and all that is Lewis one. Oh, Giselle, you put on iPad. Okay. Fine. On the worksheet, it should be on page. It's the first question on your dot and cross diagrams. Yeah, space 6. Okay, one copy here. Do I have pen? I don't have pencil. Anybody got extra pencil? Okay. Are you very behind in your schoolwork?
So big, so I got my house bro.
Yeah, it's okay. Energy is everyone. They will occupy quite a lot of your time. Give you guys about 4 to 5 more minutes to finish drawing. Then I'm going to start. Hi, Joel. We are on page 6 of the worksheet. Oh. Okay. Okay, let me extend an olive branch. Okay, so I will go through for sodium carbonate and xenon chloride first. Okay, your Na, okay, for ionic compounds is actually very simple because you know that Na, you just need to do this. Okay, there isn't really anything that you can draw for Na, alright? You don't have to draw his inner shell or whatever. Okay, and then you have your carbonate ion, which you obviously need to have a little bit more space for. Okay, carbon, central atom, you got O here, you got O here, you got O here. Okay, he has a 2 minus charge. Joel, between carbon and oxygen, who do you think is going to gain that 2 minus? Gain the extra electrons. Oxygen, right? Because he's more electronegative, correct? So the electron is going to go to him. Okay, which means that you can just choose whichever two. Okay, I leave it up to you. Okay, let's say I choose this fella and I choose this fella to be gaining the negative charge. Which means that right now the 2 oxygens at the bottom have 7 electrons each. Agreed? You got 6 that we normally have, plus this 7th fella that came from your sodium. So once you illustrate that, right, then you know, okay, between these guys, I only need 1 more electron. I won't need the double bond anymore. Okay? I got 7 electrons, I just need 1 more. Okay? Illustrate your other 2. Okay? You're going to have 1, 2, 3, 4, 5, 6. Okay, 7. And then you have your 8th fella. This guy came from Na. Good so far? Okay, we can replicate this on the other side because it's the exact same scenario. Okay, also came from Na. Okay, it is sodium's electrons. Right now, Okay, if this oxygen satisfied, this oxygen satisfied, your carbon, okay, you need to see 4 X's around him. He's in group 14. Okay, then we have our double bond here. Because oxygen is in group 16, I will need 2 more electrons. Any questions? Okay, so the Lewis structure of this fella actually looks like this, if we are currently unsure. Okay, oops. O minus. Okay, O minus. Oops. Are we okay? All right. Okay. So your central atom over here, okay? What is his shape? Excellent. Which trigonal. I got 3. Okay, do I have lone pairs? I got lone pair. Around the carbon, where? Don't have lone pair, right? But I got 3 bond pair marker or not? 3BP, 8PB. Okay. 3BP, OLP, 0LP. My shape is trigonal. There. Bond angle? 120. No issues yet? Are we okay? You okay? Can, Okay, come. Giselle, Zenon, group what? He's obviously going to be in the center. So what group is he? The last, what's the last? Group 18. Okay, so how many valence electrons does I have? 8. Okay, but I'm quite far down. Okay, I'm going to be able to expand my octet a little bit. Okay, your Fs. Okay, you're going to draw them like this. Okay, there isn't a fixed configuration for where you want your Fs to be. Okay, but I'm going to show you why I'm drawing it like this later on. Okay, so fluorine being group 17. Okay, I will need 1 more. So you just can draw like this. Okay, single bond, single bond, single bond, single bond. And then fluorines have 7. So you have 6 electrons that are not being used in your bond. Okay, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Kaylin following? Page 6. Okay, 1, 2, 3, 4, 4, 5, 6. Are we alright so far? Okay, but Xenon got 8 of his electrons, right? I'm only using 4 in bonding. How many lone pairs do I have then? 2. Okay, you can illustrate your lone pairs like this. In other words, guys, okay, Lewis structure wise are Xe dot 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 F F F F. Joel, what shape is this? I did it. Like that. I got 4 BP, 2 LP. Okay. What's this look like? Square. Oh, not bad. Square. Square what? Come on, come on. Square period. That's what pyramid. Square planar. Is your structure here. Are we okay, Joel? Yeah. Question? Question? Is there a question? Excellent question. Jaden? Hi, Jaden. Please take out your stuff. Let's get started. Okay. What about O3? Yeah, because I don't ask you because you saw we did it. Sorry? We will. 90 degrees, sorry. Square 90 degrees. Thank you. Don, finish already with ozone? Okay. How does he look like? Double bond, dative bond, single bond, lone pairs, what? 1 double bond, 1 dative bond. Okay, no, I don't put here. Then 1 lone pair of electrons on the center, guys. Okay, this is not dot and cross. This is not your answer. Okay, this is how it looks like. Alright. But yes, I will draw it like this. Okay, I got 2 like this. They have a double bond here. Okay, you have a lone pair on this fella. 1, 2, 3, 4, 5, 6. Questions? I cannot form double bonds on both sides. Your central oxygen will have too many electrons. Okay? So I'm forced to have your double bond here. Any question, guys? Eileen? Okay lah. You sure? I give you an example, you want? Okay. You tell me how come this one cannot let? This fella got how many electrons now? Too many, right? Okay, when there's too many, just transfer one of these, become a dative, finish. You get your answer. Dylan, coming. Okay, last one. BRF2 plus. Okay, if I have BR, okay, bromine, group 17, okay, and then you have F and you have F. This whole guy acquires a plus charge. Where am I taking my electron from? Answer? Why? Less electronegative. Okay, he acquires your plus charge. This fella D group 17, okay, means if I have acquired a plus charge, means I got 6 electrons only. Okay, I will have a single bond here because your fluorines both need 1. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And then your bromine has another 4 more electrons not used in your bond. Excellent. What shape is this fella? And what is his bond angle? I realize I didn't put a bond angle here, so. Wait. Two. Okay, how many bond pairs do I have? And how many lone pairs do I have? Two, right? 2 bond pair, 2 lone pair. My shape is definitely not linear. Bent. What's my bond angle? 104.5. Okay. In future, we are not going to be memorizing this. We're going to remember that typically your tetrahedral structure, okay, you have 109.5. Every time you add in 1 lone pair, okay, you go to minus 2.5, minus 2.5. Right? Okay. Apologies for skipping this one, guys. Okay, this is going to be pretty much the same scenario. Okay, you have trigonal planar, which is originally 120, but now it's not going to be 120. You're going to minus 2.5, you get 117. Are we okay? Joe? Aileen, are you good? Nice. Okay, so with that in mind, okay, we are going to move on to question 6. Okay, we'll do 5 to 7. Okay, then after that, we are going to skip question 8. Then we'll chunk quite a few of your BSCPR questions. Okay, in the gas phase, aluminum requires the following structure. Okay, we know this as dimerization. We know that typically your AlCl3 looks like this. It should be like that. But eventually, I actually get Al2Cl6 because I have a more stable structure through the formation of okay, remember, it's like that. Then you have Cl, 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 right? Then you have another AlCl3 here. What happens here? Dative bonding. Okay, your dative occurs because of 2 things. Okay, atom with free or atom with lone pair. Okay, available. Then the other fella, your aluminium must contain. Jaden, what must your aluminium contain? Not enough, okay? You have electron orbitals available. Okay, or rather empty electron orbitals available. Okay, this is the condition for your dative bonding to occur. Your aluminium right now, okay, without the dative bond should have 6 electrons only. In group 13, you form 3 covalent bonds. You have 6. I need 2 more. Yes? Okay, so your dative bonding will occur between your Cl, who very, very happily, okay, has a pair of electrons, or actually multiple pairs of electrons available for donation. Good. Recognize this? Nice. Okay, so this is the word version. All right, your Al is electron deficient, empty p orbital. Okay, so your Cl will donate its lone pair of electrons via the formation of your dative bond. All right, this is the word form. Okay, I don't think it's very difficult. All right, just keep track of the keywords that we are relying on. Okay, electron deficient slash empty p orbitals. Therefore, you have donation via dative bonding. Good. Okay. No issue, yes. Okay, as we continue doing more questions, it's going to become a little bit easier to digest. All right. Answer okay? Dylan okay? Okay, Dylan, come. He has a similar structure. How would I draw gallium chloride?
About the same thing.
Pretty much, almost the same. Okay, your GA, okay, you got Cl, you got Cl, you got Cl, GA, you got Cl, you got Cl, you got Cl, and then you have dative bonding from donation, from donator to acceptor. Simple, like this. Okay, this is how your typical structure looks like. All right, what types of bond am I forming here? No, excellent. I don't mean sigma or pi. I mean, what is it like? Covalent? Is it all covalent where there's sharing, or is there some dative bonding? How many of each? 2 datives and
Six sharing.
six covalent bonds. Correct? Yes, hi.
But when the CL MRIs other
With what?
other like ALCL, GCL.
Oh yeah. So but down here I'm talking about this fella. We have done our AL example already.
Like what did I
The dimerization can occur across different ones. So let's say I can have GA here as well. Yes, okay. But if I talk about your similar structure to AL2 CL6, we won't expand indefinitely. You answer according to what the question requires you to answer. Can he continue forming your longer chain? Definitely possible. But it's not what we're focused on for this question. That's all. Yeah. Good. Okay. All right. Let's go. Question number 7. What? What's that? Oh, you did it already. Good. Okay, so question number 7. All right, carbon monoxide and boron hydride. Boron hydride is very easy. Okay, I'll just do a simple one here. Okay, this is boron hydride. Boron is in group 13. Okay, this is nothing. However, I'm more interested in how you guys are going to draw CO. Okay, CO. I'm gonna ask a couple of questions. Dylan, how many electrons does I have versus how many electrons does I need if I'm carbon? Need? 4 need 4, right? Okay. Makes sense for it to be like this. For carbon, for oxygen, oxygen got 6, right? I need 2 only, right? Yeah, we like that, ma. Make sense? No? What's wrong with it? How many?
and 10
10 electrons. So when you have too many electrons, what does I need to do?
10 electrons. 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 10 electrons.
dative. Okay, your dative bond will arise from you removing one double bond. Double bond. So I'm going to take this, okay? I'm going to take these people and I'm going to change him into a dative bond instead. So your carbon is actually going to have a dative bond with oxygen. Okay, how would I draw this out? Okay, like that. That is carbon monoxide. It is a configuration that allows both carbon and oxygen to achieve the desired number of electrons. Sorry, wrong. The arrow will be from oxygen. But yeah. Can? Okay, so your electron, okay, the guy who has too many electrons will be donating your electrons towards carbon. So carbon, okay, now here I got 8. Oxygen also have 8. Simpler? Okay. Question? Okay. How to combine them? Can you guys draw it up and see? Pay close attention to how it is written. It is written this way for a reason. Finish? Yeah. Are you okay with staying back a little bit after this? 10, 15 minutes extra. Yeah? Okay, we'll end a little bit later for this because we have quite a bit to go through. Okay. Can or not?
Also.
Yeah. Okay. The lesson to be learned here is to focus on how the fella is drawn. Okay? Because if you realize, right, you definitely got dative bond, right? Because boron currently only has 6 electrons. So you confirm have a dative bond. The problem is that both oxygen as well as carbon possess a pair of electrons that they can use in their bonding. Agreed? Okay, both can behave as donators. Who is the one that's donating? Pay attention to who is connected to your boron. Okay, carbon's dative bond is over here. You all get this? Okay. Don, okay? You use oxygen to bond. Okay. Hello, alright? H3BCO. Not COBH3. Not the same thing. Okay? Answer? Question? Yeah, okay. My answer, the C of X. This one, so the C floor. Nothing. I got 4 of my own mark. Yeah, it's fine. Can? Not okay? What's the question? Carbon, sorry, that's not what? Carbon has 8 electrons. Yeah, I mean, as much as possible, I will try to balance both with 8 electrons, right? Your carbon monoxide, your carbon already got 8 electrons with you. So after bonding, okay, I cannot take any more, but I can contribute to your boron atom. I can donate. Because this pair of electrons between us actually belong to both people. Okay? This highlighted one belongs to both carbon as well as boron. Oh. In this case, your data might follow up. Okay. You are still going to have your oxygen like that, right? Then your boron is over here. Then you have your HHH. This, if we wanted this one, then we will have to phrase our question a little bit differently. But in this case, your carbon still has 8, your oxygen still has 8. Okay. Okay. Any questions? Dylan, good. Okay, yes. If give away lah, I'm not giving away here. Dative is not giving away. Dative means I form a bond with you. The pair of electrons is donated, but it's not transferred. I'm not forming an ion here.
How many electrons you have?
Carbon, yes. Oxygen also 8. Everybody has 8 except for the hydrogens now, in either of the examples. Cool. Okay, we are skipping question 8. Alright, if you want to go and do it by yourself, okay, not really the concern. Okay, I want to talk about question number 9 first. Okay, so we're going to do question 9. Alright. And then afterwards, I'm going to give you guys some time to try your luck with the rest of the questions. Okay? The characteristic smell of garlic is due to alene. Okay, wow, this big ass compound. Okay, what we expect the bond angles to be to the nearest 10 degrees. Okay, to the nearest 10 degrees. Let's take a look at X first. Okay, around this carbon, Tyler, what is my shape? In terms of, okay, how many BP first? How many LP first? 3 BP, 0 LP. What's my shape? Trigonal, planar angle. Okay. Let's move on. Let's talk about S. Done? How many BP? How many LP? 3 bond pairs. 1 lone pair. Shape? Haven't memorized. Trigonal, pyramidal. Okay, do something else. Trigonal, pyramidal. Okay, trigonal, pyramidal. My bond angle will be what? Normally at 109.5. I have a lone pair though. 107. Okay, to the nearest 10 degrees, I will be. Okay, 110. We have our answer already, huh? Catching ball. Okay, last one. Dylan, this fella. 4 BP, how many LP? 0, okay. Still happens. Birth, hello. Well, walao eh. it is tetrahedral. Okay, tetrahedral bond angle is 109.5. Okay, we have 110 as well. Question? No? Not again? Excellent. All right, good. Let's carry on. Okay, can you guys try for question number 10? Okay. And 11. You can. Finish already. Oh. Yeah, look at question 19. Same, right? Oh, school take on same question bang on. Boring. Okay, nice. Let's continue, yeah. Finish already, excellent. 10, 11. Okay, let's go. So you have N2H4. Okay, I trust this should not be too much of an issue. All right, you have your lone pair. Okay, BP. Okay, 3BP, 1LP. Shape, trigonal pyramidal. Why? Lone pair, bond pair repulsion, yes. Lone pair, bond pair repulsion. Stronger, weaker, what? Stronger than bond pair. So what do you expect the angle to be? 107. Okay. Apart from this, all right, the link between your trigonal pyramidal to over here, okay, will be to talk about how we derive the shape. Y is shape. Okay, how do I achieve this shape? Is to minimize repulsion. Correct? You want to arrange them as far away as possible to minimize the repulsion between them. Okay, so that you are not going to have any instability. Okay, 3BP, 1LP. Not what am I doing? Okay, you guys already did it. 3BP, 1LP, far apart as possible to minimize repulsion. Okay, and then you bring in the repulsion being stronger than bond pair. Therefore, your smart, when I start talking, okay. Therefore, you can trigonal pyramidal with a bond angle of 107 degrees. Are we okay? Okay, you all should have gotten the large portion of this, yes? Yes, I.
The drawing, right? Must it follow the
No. Not across the Lewis structure, best two. Okay? Sure, alright. Nice. Okay. Joe, you do question 11 as well? Okay, so let's see first. Okay, so you have PCl3, PBr3. Okay, what will determine the size of the bond angle here? Not quite. It's like, okay, can you tell me the shapes first? Okay. You know that you have three CLs, right? Okay. See, what the hell is wrong with that? Okay, but you have three CLs. Okay, but your phosphorus got how many electrons? His own electron. 5, right? So if I'm using 3 for bonding, that means how do I have lone pair? How many? One lone pair. Okay? One lone pair. Then you have your CL here, CL here, CL here. Pa. Yes, yes. Okay. Do you agree that it's gonna be the same for your BRs? So both of them have the same shape, which is still trigonal pyramidal. Okay. What will determine their bond angle? Both of them got 3BP, 1LP. So it's not about the repulsion. What else? It has to be about these people. Not about the number of electrons. Everybody has single bond. It is about between CL and BR, what is the main difference between them? It is electronegativity. With CL, do you think he's more or less electronegative? Which means the electrons are going to be pulled this way, right? Further towards CL, correct? then down here the electrons are a bit closer. This has some consequences, isn't it? Because the electrons are closer here now. Okay, electrons are closer together, they push each other a little bit more. Agree or not? Okay, your smaller bond angle exists for him. Makes sense? Yes? Haley, make sense? Okay, so when you're explaining that, we will have to rely on this. Okay? Your CL is more electronegative. Okay, I'm not going to give you guys time to write down everything. Okay, just keep track of what is important. Okay, the bonding electrons closer to Cl. Okay, and if your bonding electrons are closer to your Cl, okay, instead of saying less crowding of electron density, some schools don't allow this. Okay, you can also say, okay, just lower electron density around your phosphorus atom, leading to weaker repulsion, okay, between your bond pairs. Therefore, your bond angle becomes smaller for your PCl3 compared to PBr3. Alright, this is it is about us knowing what will affect that bond angle. Okay? Okay, you have electronegativity of your terminal atoms, which is this case, or you can have electronegativity of your central atom. Good. Okay, following? Don, are you okay?
No. No.
Why? The electrons closer to the P, right? They will push themselves out.
Small.
Yeah. Smaller means like down here, you see how far away they are as compared to these guys being very close. The fact that they are all so close, everybody will push each other away. Good. Oh, sorry. We are not doing question 12, by the way. The next question we do is question 13. Sorry? The repulsion for this, yes, is bond pair bond. We cannot bring in lone pair bond pair here because both got the same number of lone pair bond pair. Right? Both 3BP, 1LP. Ma. The lone pair bond pair repulsion will still be stronger. But if I'm comparing lone pair bond pair versus lone pair bond pair, but this time your bond pairs are further away from your central atom, then the further away you are, the smaller end. This ruling, this ruling that LPBP is more than BPBP, right, is true all the time, regardless of how close or how far away it is. Okay? But the problem with this one is that I have both of them have the same lone pair and bond pair configuration. Same shapes on. So all that matters is how close the electrons are to each other. Okay? Alright, we're skipping question 12. Some basic shit. Okay? Let's do question 13. Okay, the chemistry of group 13 elements. Okay, aluminum chloride is used as a halogen carrier. Draw the dot and cross diagram for the AlCl4 minus ion. Okay, AlCl4. Al, okay, you're gonna have a bunch of Cls. Cl. Okay? Now, this entire thing has a -1 charge. Your electron gonna go to who? Joel? Cl. Okay, pick one. Doesn't really matter. Alright. So Cl having 7 electrons already. Now I have 8 lah. 7 plus 1. Okay. This fella already got noble gas configuration already. But, okay, we need to remember that right now, okay, you have your single bond with everybody else. Okay, then you have your Cl, Okay, all your Cls have your 8 electrons. There's only one coconut who don't have. Okay, so with that in mind, guys, okay, you have 1, 2, 3, 4, 5, 6. Note the different symbol I use here because this electron came from somebody else. And then you are going to have a, between this guy, okay guys, between him and between him, what kind of bond do I form? Agree. Okay, dative bond. Okay, we're drawing looks kind of shit, but this is how we are going to draw it now. Yes? Okay, good. What's the shape? Break it down first. How many BP, how many LP? If we are unsure. Yeah. One angle? One zero seven nine. 1079, huh? 109.5 lah. Easy? Easy, right? Can tell it's getting easy for you guys. Well done. Let's go. Okay. What about PCl3? Okay. I'm not too interested in the drawing. Okay, we just did him. All right. It's going to look like this. Okay. Your shape is trigonal planar. Okay. Sorry, trigonal pyramidal. What's important is this fella polar or non-polar? Giselle? Polar. Towards which direction? Downwards, okay? Your Cl is more electronegative. Okay, you have your net dipole moment downwards. Are we okay? Good. Angela? Dylan? Nice. Okay, can I do one more question with you guys? Okay, I'll just do it with you guys so we don't have to waste any time. Let's do question number 14. Okay? SO2, CO2. I want similar shape, huh? Okay? I'm not worried too much about the angle here. Okay, but I want the shape to be very similar. SO2, CO2. Let's draw them out. Okay, CO2. In MCQ, guys, you don't have that much time. Don't bother drawing one dot and cross or whatever shit. Okay, this fella is definitely linear. Straight away. Yes? Okay, what about SO2? Is it also linear? Sulfur got how many electrons?
Okay. It's bent, right?
He's bent, yes. Because he has 6. I have a lone pair on top. Wrong already. Move on. MCQ must be fast. Ready? Let's carry on, yeah? Dylan, pH3. What does this fellow look like? Is it like that? No. Phosphorus group what? So, do I have lone pair on? You got 5 valence electrons, bro. Correct or not? Like that, ma? Okay, what about SO3? No lone pair, right? I have this. Trigonal planar. One trigonal planar, one trigonal pyramidal. Wrong. Move on. H2O. Kala? Is it linear like this? Nice, nice? No. Okay, he is what? He is bent. You have 2 lone pair, 2 bond pair. Okay, BRF2. How? Oops. Is it like that? Keep it simple? Yes, no? No. Why? I got negative charge. Negative charge go to? Okay, remember for your Lewis structure or for dot and cross, your negative charge, your electron added goes to the more electronegative. So who is it? Agreed. Okay, so the guy requires minus charge. All right, you have your dative bond formed here. Okay, bromine has 7 electrons in total. You have 1, 2, 3, 4, 5, 6, and then your 7 fellas used in the bond with the other fluorine atom. But that's not really our concern. Our concern is the fact that they both don't have the same shape anymore. Okay? Good. Okay, don't need to think so much in MCQ. We don't have time for that shit. Last one, XeF4, ICL4. Xenon. Giselle? How many electrons does he have?
8.
8. XeF4 hence looks like, is it like this? Square pyramidal. You have lone pair on top, lone pair below. Okay, what about ICL4? I got 7 electrons. Okay. Do I form like this as well? Cl, 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 Cl. Yes, okay. Negative charge go to who? Negative charge go to who?
I see.
Yes. I or Cl. Your negative charge will go to the more electronegative atom. Okay, in this case, it is chlorine. You can pick whichever one you want. Okay, which will mean that this fellow already got 8 electrons. This bond that exists between them is a dative one. Yes? Okay. But iodine got 7 electrons, ma. I am using 1, 2, 3. I have 4, 5, 7. Exactly. We got an answer. Both also square planar. Good. Good. Answer okay? Can I? Okay. So with that, guys, I am stopping and bonding once and for all. Okay. You all got a lot of questions to do. All right. I will send the answer key where I have recently added somebody, but I think he's joining next week already. So I will send y'all. I think I'll send y'all individually or kick him out of the group that's first. Okay? Must be fair to y'all lah. Must be fair to y'all. Okay? Now, there's a piece of foolscap on your table. Okay, you can just take one sheet or you can take multiple if you want to. Okay, what we are going to do right now is a simple, I would say consolidation. Okay, I'm going to go through a summary of chem bonding. Okay, it's going to be quite messy. I prepared it here. Okay. Along with this summary, I'm also going to provide you guys with the notes and the page number where you can find the relevant information. Huh? Yeah, you can use iPad if you want to. Okay, but the point is to keep it together in your notes. So if you have foolscap paper, then you can slip it to the back or whatever. Alright, come. So the first thing we learned, okay, we have your ionic, okay, and metallic. Surprise, I'm not going to go through anything here. Okay, I'm not going to bother. Alright, we are going to go through mainly covalent bonding. Okay, your covalent bonding occurs because you have a share of electrons due to